Welcome to Carlton's Math Corner. Today we are going to talk about sample space. At this time, please make sure that you are ready to learn. Our target today, or one of our targets today, is I can list all the possible outcomes in a probability experiment. And what that means to list all the possible outcomes is it's called sample space. And so what basically you're doing is either you're making a list or you're making a tree diagram, and I'll show you what that is. But you're trying to list all the different things that could possibly happen for a certain event. For instance, if a vendor sells vanilla and chocolate ice cream, and then customers, there's a T in there, customers can choose from a waffle or sugar cone and either hot fudge or caramel topping. Find the sample space of all the possible orders of one scoop of ice cream in a cone with one topping. So to make a list, this is one option for you to do, is kind of make a table, just make a list of things and make sure that it's organized. What I would do is start off with one of the choices, and in this case there's vanilla or chocolate, and notice I have separated them. So vanilla is at the top and chocolate's at the bottom, and so with that said, no matter what, if you're gonna have an ice cream cone, you gotta have some kind of ice cream that goes in it. And there's only two choices, at least at this place, vanilla or chocolate. So V I put for vanilla, C for chocolate. And then it says customers can choose from a waffle or sugar cone, and then hot fudge or caramel topping, or caramel, however you want to say it, topping. And so what you need to figure out, and what I basically is just assign letters. So waffle, I put a W, and sugar, I put S. Then hot fudge, I just put H for hot. And then caramel, I put C, or caramel, I put C. And so now basically I just had to figure out how many different options could I have. Well, if I had vanilla ice cream, okay, I could choose a waffle or sugar cone. So I put waffle, sugar cone. But then I could have hot fudge, or I could have caramel topping. Hot fudge or caramel topping. So I could have vanilla, waffle, hot fudge. Vanilla, waffle, caramel, or caramel. Then vanilla, sugar cone, hot fudge, vanilla, sugar cone, caramel topping. Okay. Then on the bottom, I could have the same exact order. However, my cone is switched to or not my cone, my type of ice cream is switched to chocolate. So instead of a V in front, I just changed everything and put a C in front. So if I count up all these different possibilities, I notice that I get 8 possibilities. And I can check my answer by using what we call the fundamental counting principle. And what that is actually it's fundamental counting principle. And what that is basically all I'm doing is I take all my options and I multiply them together. So I had 2 options for ice cream times 2 options for cones times 2 toppings. 2 times 2 is 4 times 2 is 8. So I should have a list of 8 different things, and that is one way for me to check my answer. And it does work. Another way that I could list, if you don't want to make a list of all the different types, you could use a diagram. And this is what I mean by a tree diagram. First of all, I started off with, at the top, I had, this was ice cream, right? Yep. And so I started off with different ice cream flavors. I had vanilla or chocolate. Then I branched off. If I have a vanilla ice cream, I could have a waffle cone or a sugar cone. If I had chocolate ice cream, I could have a waffle cone or a sugar cone. And so this was cone. That was the next layer. And then the bottom layer was I could choose hot fudge or caramel, hot fudge, caramel, hot fudge, caramel. And notice I have it branched off on each of these because I could have vanilla, waffle, hot fudge, vanilla, waffle, caramel. So I could have each one of those, and notice it just keeps branching off of the one before it. And so this was topping choices. And no matter how many layers I have, I could actually keep going. I just have to make sure that I am branching off of every single thing so whatever I end up with, I have to have a branch off of that. And so if I look at all this, the bottom one is actually the total number of different choices I would have. So 2, 4, 6, 8, I still get 8. Still 8 possibilities. Now our next target is I can use sample space to find probabilities. So now I'm using sample space to figure out what the chances of something happening. So Brianna spins a spinner with 4 sections of equal size twice, so 2 times. And they're labeled A, B, C, D. If letter A is spun at least once, Brianna wins. Otherwise, Odell wins. Find the probability that Odell wins. Well, first of all, I created a tree because I thought that would be quicker for me. This is the first time that it's spun. Let's see. We'll just say spin 1. Whoops, I want to put it over here. Spin 1. Okay, that is, she basically spin 1, you could spin A, B, C, or D, right? Spin 2, you could spin A, B, C, or D, but you also have it put together with spin 1. So if I spun an A, I could get A, B, C, A, D. Or I could get B, B, C, D. Or C, B, C, D. Because I'm spinning it twice. So I could land on an A first, and then the second time I could land on all the other letters are a possibility. Okay? Now the question is, when does Odell win? Well, Odell wins if A is not spun at all, because Brianna wins every time an A shows up. So let's highlight the things where Odell would win. Okay? Would she win in this category? Because this would say that I would spin an A and an A. An A, B, A, C, A, D. Would she win any of those? No, because there's an A in it. We can't have any A's. Okay? Would she win if she spun BA? Nope, because there's an A. But would she win if it was BB? Yes, she would win there. How about BC? Yes. How about BD? Yes, because there's no A. How about CA? Nope, there's an A. How about CB? Yes. CC? Yes. CD? Yes. How about DA? Because there's an A. How about DB? Yes. DC? Yes. How about DD? Yes. So how many times could Odell win? She could win, count them up, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times out of how many total possibilities? We'll just count up the bottom ones. 4, 8, 12, 16. There are 16 possibilities. So she could win 9 out of 16 times. So how many times could Brianna win? Well, she gets all the rest. So that means she would have, because they should add up to equal 1 whole, and so she would get all the rest of them, which would be 7 out of 16, because 9 plus 7 is 16. So this would be Odell, and this would be Brianna. I think I spelled Odell wrong. Let's add another L. Okay, and so actually Odell has more chances of winning. Does that guarantee that she'll win? No. I mean, it's still all probability. Brianna still has a chance of winning. It's just Odell has more of a chance winning. Okay, so these are all the possible outcomes if I spin 2 dice. So I'm going to spin 2 dice. These are all the different possibilities that I could get. I could get 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, etc. Okay, so all these different pairs are what I could get. And it asked me, what is the probability of getting a pair? Well, look at all the pairs. We have 1 set of pair, 2 sets of pairs. Here's 1, here's 2, here's 3, here's 4, here's 5, here's 6. There are 6 possibilities. How many total possibilities are there? Well, just go like this, multiply them. It looks like a multiplication array. So here's 1 pair, 2 pairs, 3 pairs, 4 pairs, 5 pairs, 6 pairs. 6 times 6. 6 times 6 is 36. Now we can't leave this fraction the way it is. We need to simplify it. So my answer would be, if I divide it both by 6, I can get 1 out of 6. So 1/6 chance of rolling doubles or pairs. We're rolling a sum of less than 7. That means if I add these pairs together, they're less than 7. Okay, so let's do a different color. Well, this is less than 7. That's 1 plus 1 is 2. That's 3, 4, 5, 6. But that one adds up to 7, so that doesn't work. How about this one? Yep. That's 4. That's 5. That's 6. 7, and that's 8. Nope. How about this one? Yes, 5, 5, 6. Not 7. 5, 6, and that's 7, 8, 9, 10. Nope, it's getting too much. Here's 6, and that's 7, and nothing else. So count these up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 different possibilities we could get less than a sum of 7. And 15 out of how many total? Always, in this case, 36. Always, that's the key number, 36 different possibilities. Is there something you could divide 15 and 36 by? Yes. We could divide both of them by 3, and we would get 5 and 12. 5/12 would be my answer. I'm not going to do rolling a 3 because I think we can figure that one out, but I'm going to move on to the next one. It says if the probability to land on Boardwalk Monopoly is 0.036, what is the probability of not landing on it? Well, remember probability, if I say that they are, we're trying to find a percent, or we're trying to get to a whole amount. And so we're trying to get to 1 whole. So if I know that the probability of Boardwalk is, excuse me, is 0.036, I can subtract that from my whole amount and figure out what is left of probability of not landing, because that's completely opposite. So 1 minus 0.036 is 0.964. And that would be my chance of not landing on it, because they're complete opposites of each other. Remember, these are those complementary events where they're opposites. So if I know what's landing, then I need to figure out what's not landing. For tomorrow, would you please complete the following problem of the day, or ticket problem? Thank you so much for joining me at Carlton's Math Corner, and I look forward to meeting with you again.